Welcome back to the deep dive. For anyone deep in the world of Kubernetes, you're likely familiar with managing, long-running services and applications. But today, we're cutting to the chase on the often underestimated yet absolutely crucial tools for automated tasks. Jobs and cron jobs. These are really about ensuring your digital chores, whether it's a one-time script or, say, a recurring backup, get done reliably and then get out of the way.
Exactly. Our mission today is basically to demystify jobs and cron jobs. We'll explore what they are, unpack why they're so vital for efficiency and reliability in a containerized environment, and then we'll dig into the nuts and bolts of how they actually operate within Kubernetes. We've poured over your sources to sort of distill the most impactful insights, giving you a clear, actionable understanding.
Right. You might be prepping for a critical deployment maybe, or just intensely curious about optimizing your cluster. But by the end of this deep dive, you'll have a much clearer picture of how to manage those one-off processes and repetitive tasks without breaking a sweat, freeing up valuable resources, and frankly, your own time. Okay, let's unpack this. So we're talking jobs and cron jobs today. Now, for those of us navigating Kubernetes, we're kind of used to deployments and stateful sets, right? Things that keep applications running continuously. How do jobs and cron jobs fundamentally differ from those? What problem do they specifically solve?
Great question. Well, the core difference is that jobs and cron jobs are Kubernetes resources explicitly designed for tasks that run to completion and then they terminate. Unlike deployments, which, aim for continuous uptime, a job is all about getting a specific task done successfully, once, or maybe a defined number of times. To elaborate a bit, a job is a Kubernetes resource. It creates one or more pods to perform a specific task, and then, crucially, it makes sure that task completes successfully. Once its mission is accomplished, the pod's tied to that job. They just terminate, they don't hang around. Think of it as telling Kubernetes, do this single thing, let me know when it's finished.
Okay. And then the cron job builds on that concept, right? What's its role in this picture?
Absolutely. The cron job is the scheduler. It's a resource that runs those jobs, but on a predefined schedule. Very much like the familiar cron utility in Linux, actually. It automates repetitive tasks by creating new jobs at specified times or intervals. So if a job is do this thing once, a cron job is more like do this thing every Tuesday at 3 a.m. To put it in a way that hopefully really sticks, think of a job as like a one-time errand, cleaning your room maybe. You do it, you finish it, and then you stop. A cron job, though, that's like setting a reminder to clean your room every single week. It automatically starts that task on schedule. This distinction really emphasizes it, I think. Jobs handle those finite one-off tasks. Cron jobs manage the repeating ones, and both make sure they complete reliably and then, tidy up after themselves.
Yeah, that clean your room analogy really helps clarify it. Simple but effective. So what are some practical real-world examples? Where would you typically use a job versus a cron job?
Excellent point. For a job, imagine you just migrated your application to a new database. You need to run a data migration script, transfer all the existing user data. That's critical, but it's a one-time thing. You define a job, it runs the script, ensures all data is transferred successfully, and then the job completes. Done. For a cron job, think about routine stuff, like scheduling a nightly backup of your production database. You want that to happen automatically, ensure data integrity without someone having to remember. Or maybe generating daily, weekly, or monthly reports for business intelligence. These are tasks that just demand consistent automated execution.
Okay, so clearly for batch processing, data analysis, system maintenance, things that don't need continuous uptime. But beyond just knowing what they are, for you, our curious listener, the real question is why? Why should these particular Kubernetes resources be on your radar? What are the fundamental problems they actually solve?
That really is the critical part. The primary reasons for using them are pretty compelling, and they directly address common headaches in application management. The first, and maybe often underappreciated insight, is the task completion guarantee. Jobs don't just run, they ensure tasks finish successfully. They'll even retry failed pods until completion. This means if your data import script hits some transient network error, Kubernetes won't just give up, it'll restart that pod. But here's a deeper insight, actually. This forces you to think about idempotency in your task design. If your script isn't idempotent, meaning can run multiple times without causing bad side effects, then retries become a liability, not a feature. That design discipline is a crucial, often overlooked benefit.
Ah, that's a really good point about identity. Hadn't quite thought of it that way.
Yeah. Secondly, there's scheduled automation. Cron jobs automate those repetitive tasks, like the daily backups or report generation we talked about. They run jobs on a strict schedule. This just dramatically reduces manual effort and ensures consistency. It takes the human error element out of critical routine operations.
That makes perfect sense for ensuring tasks get done reliably. But what about when things inevitably go wrong? Or resource usage, which is always a concern.
Excellent points. So third is robust failure handling. Beyond just simple retries, jobs can be configured with a back-off limit. That controls how many times a pod will be retried before the job itself is marked as failed. You can even set an active deadline seconds to prevent a task from running forever if it gets stuck. Gives you a clear cutoff point. This really improves reliability for potentially flaky operations. Fourth, and this is huge for anyone managing cloud costs, is resource efficiency. Pods created by Jobs and CronJobs, they terminate after completion, they free up cluster resources. Think about the direct cost savings compared to, say, keeping long-running pods idle in a deployment, just waiting for a task that only runs once a day. This directly impacts your infrastructure bill. It's not trivial.
Right, you're not paying for idle compute.
Exactly. And finally, scalability for batch workloads. Jobs support parallel execution. You can define parallelism to run multiple pods at the same time. Imagine processing a massive data set. You could run it across many worker pods simultaneously, significantly speeding up the completion time. Invaluable for large-scale data processing.
Okay, this is where it gets really interesting for me. What happens if you don't use these? If you try to sort of roll your own solution or just ignore the problem, what's the practical impact?
Well, without jobs, you'd be stuck with manual management of one-time tasks. That likely leads to incomplete operations or wasted resources if pods fail and don't terminate properly. Imagine running a big data migration manually, constantly checking its status, restarting it if it fails. It's a nightmare.
Yeah, no thanks.
And without cron jobs, scheduling those repetitive tasks would demand external tools, maybe an external cron service, or custom scripts with their own bespoke retry logic. That just dramatically increases complexity, maintenance overhead, and, let's be honest, the risk of missed or even duplicate executions. It gets messy fast.
Okay, let's bring this home with a real-world example from the sources. Imagine managing a financial application inside Kubernetes. A job could, say, process a one-time tax calculation for the big yearly report. It ensures it completes successfully, reliably, even if it has to retry a couple of times. At the same time, a cron job could schedule that nightly task to aggregate transaction data. It runs precisely at 2 a.m. daily, maybe using a cron expression like 02. This ensures your financial reports are always up to date without any manual button pushing from your team. It really highlights how much manual overhead these built-in resources can just eliminate.
Exactly. It makes those kinds of essential but tedious tasks just happen reliably.
All right, we've covered the what and the why, which is crucial, but the real magic is often in the how. When you define a job or cron job, what's actually happening behind the scenes in Kubernetes? How does it make these tasks run so reliably? Let's dig into the mechanics a bit.
Absolutely. Let's walk through the basic workflow for jobs first. You start by defining what Kubernetes calls a job template. This is essentially a blueprint for the pod, or pods, that will run your task. Within this template, you specify the container image, the command or script to run, all the usual pod stuff. But you also define crucial parameters like completions. That's how many times the task must successfully complete, usually just one for a simple task. And parallelism, which determines how many pods can run at the same time if it's a multi-part task.
So you define the what and how many.
Precisely. For example, you might define a job to run a container that processes a dataset, ensuring it completes just once, successfully. Completions. 1. Then comes the job execution and completion phase. The job controller, which is part of the Kubernetes control plane, sees your job definition. It creates one or more pods based on your template to execute that task. Crucially, if a pod fails, maybe it crashes, maybe the node dies, the job controller will automatically retry it. It respects the back-off limit you define in the job stack.
And that back-off limit stops it from retrying forever.
Exactly. It's often an exponential back-off, too, so it waits longer between retries to avoid hammering a system that might be temporarily overloaded. You can also set an active deadline seconds. If the job runs longer than that, Kubernetes will mark it as failed even if pods are still technically running. It's a safety net against runaway tasks.
Got it.
So for instance, that data migration job runs a pod. If the pod fails due to, say, a temporary network glitch, the job controller restarts it. It keeps trying until the task succeeds or it hits that back-off limit.
Okay, that deep dive into how a single job ensures completion is fascinating. The built-in retry logic is key. But what about all those repetitive tasks we mentioned? The daily backups, the weekly reports, the ones that need to run consistently. That's where cron jobs come in, right?
Yeah.
How do they leverage this job mechanism to manage the scheduling?
Right. For cron jobs, the workflow is really about orchestrating those individual jobs over time. You start by defining a cron job. The most important part here is the cron schedule. You specify this using a familiar cron expression. Like you said, 02 means run at 2 a.m. every day. The fields are minute, hour, day of month, month, and day of week. Standard cron stuff.
Just like on Linux.
Exactly like Linux cron syntax. This cron job definition also includes a job template. It looks almost identical to the template you'd use for a standalone day. Job specifies the container, command, etc. Then, at each scheduled time, the cron job controller automatically creates a new job resource based on that template. That new job then, in turn, creates the pods to run the task. So a cron job set to run a backup job every night will literally create a brand new, distinct job object at 2 a.m. each morning to handle that specific backup run.
Okay, so it's not reusing the same job, it's creating fresh ones each time.
Correct. And that's important for tracking and history, which leads to cron job management. Cron jobs also handle history limits. You can configure successful jobs history limit and failed jobs history limit. These tell Kubernetes how many old completed or failed job objects and their associated pods to keep around. This stops your cluster getting cluttered with metadata from thousands of old runs.
Keep things tidy.
Yes. They also manage concurrency via a setting called concurrency policy. This controls what happens if a new job is scheduled to run before the previous one is finished. You can allow them to run concurrently, forbid the new job is skipped, or replace the old one is canceled.
Oh, that's useful. So you could prevent two backup jobs from stomping on each other.
Precisely. It's like a smart traffic controller for your scheduled tasks. Prevents potential conflicts or lets things run in parallel if it's safe for your specific workload.
That sounds incredibly robust, especially with the retry mechanisms in the underlying jobs and these concurrency controls. But, in the real world, sometimes things just keep failing. Does Kubernetes just throw its hands up if a job scheduled by a cron job keeps hitting that back-off limit night after night? Or is there a strategy for persistent issues?
No, it doesn't just give up silently. While the individual job will eventually retry based on its back-off limit and then mark itself as failed if it can't succeed, that failed status is a crucial signal. It tells operators, hey, something went wrong here. You need to investigate. Monitoring tools can pick up on this. But importantly, the cron job itself will continue its duty. Even if the job created last night failed, the cron job will still create a new job tonight when the schedule hits.
So it keeps trying on schedule.
Yes. It ensures your tasks keep attempting to run according to the schedule, even if there was a transient issue before, or even a persistent one that needs fixing. So if that backup job fails one night due to some temporary glitch, it might retry, say, up to 6 times based on its back-off limit. But regardless of whether it's succeeded or failed eventually, the next night at 2 a.m., the cron job faithfully creates a brand new job instance to try the backup again. Gives the system another chance at success after potential issues might have cleared.
Right, okay. That makes a lot of sense. The cron job is persistent about scheduling, even if the individual executions have problems.
Exactly. So bringing it all together, jobs are like telling Kubernetes, do this specific chore, please make sure it gets done. Cron jobs are like setting a really smart self-healing calendar reminder for those chores that need to repeat. They just make it incredibly easy to run and manage tasks like data processing or backups reliably. They ensure completion, they run on schedule, they clean up after themselves to save resources, and they give you clear signals when things aren't going as planned.
Okay, so what does this all mean for you, our listener? We've journeyed through the what, why, and how of Kubernetes jobs and cron jobs. We've seen how they can truly transform these, manual, often error-prone tasks into automated, reliable processes that actually respect your cluster's resources. It really takes the manual burden off. I mean, who wants to wake up at 2 a.m. just to check if a backup script actually ran right?
Nobody.
Right.
And yeah, if we connect this to the bigger picture, it's really about shifting your mindset, moving from reactive problem solving, oh no, the backup failed again, to proactive, automated task management. It's an essential building block for truly robust, self-healing applications in a containerized world. It lets you actually trust your automation rather than constantly needing to babysit it.
Yeah, the simplicity that clean your room analogy really does stick, doesn't it? It helps demystify what can seem like complex automation, but it also gives us those hooks into the specific Kubernetes parameters like completions or back-off limit.
It does, and the core idea that Kubernetes doesn't just run continuous services, but also diligently completes these individual and scheduled tasks with built-in resilience. That's a really powerful paradigm shift, I think, for how we manage workloads and even how we design our applications.
So for you, our curious learner, the next time you're thinking about automating, say, a one-off report generation or a nightly data sync, or even a large-scale batch data analysis, you'll know exactly where to look to build that automation directly into your Kubernetes cluster using jobs and cron jobs. Now, for a final provocative thought to leave you with, given how elegantly jobs and cron jobs handle task completion, resource efficiency, and those built-in retries, what other one-time errands or scheduled cleanups in your current workflow, maybe even things outside traditional IT operations, could potentially be revolutionized by this kind of reliable, scheduled automation?
Think about the possibilities there.